Welcome. This is a demonstration of the Civil Engineering Review course for the Fundamentals of Engineering exam. This course is similar to what you might get at your local institution, where you're asked to come to that institution for 8 hours a week for 10 weeks. The difference is you don't have to drive this time. This course is offered streamed over the internet straight to your computer at home or at work, and you can pick the time that you have available in order to do the review. Our course is tied heavily to the NCEES Supplied Reference Handbook. We're going to be using the pages out of that handbook and show you what the formulas are and how to use those formulas. This handbook is not the end-all for your exam because there are no sample problems in it. There are no calculations of any type. And there's a lot of material in here that isn't often asked on the civil engineering portion of the Fundamentals of Engineering exam. And so we'll be going through it in detail to see what is and what is not used often on the FE exam. Here are the topics that we'll be covering in this course. As you can see, they are all the major portions of the NCEES Handbook for Civil Engineering. Each one of these topics will be covered by a slideshow multimedia presentation by the professor, much like what you're seeing now, and then many problems dealing with that material. All of the material is dedicated to solving problems, and the solutions to these problems are provided. In the area of surveying and transportation, we do take a look at these popular formulas for calculation of volumes, irregular volumes. We'll also be taking a look at horizontal road curves, the geometry of road curves, and the performance of road curves. We'll be looking at vertical curves, both crest and sag curves, and we'll be looking at their description and their performance. We'll even be looking at the performance of these curves at night and how to specify the parameters of these curves according to sight distance. And we'll finish this section with some traffic flow theory, where we talk about the relationship between speed cables and the density of traffic flow on a highway. In Part 2, Soil Mechanics, we'll be dealing with a lot of different subjects. All of them because there is a great deal of information in the NCEES Handbook on earthworks and soil mechanics. So we'll be talking about how to classify soil according to the size distribution graph and a series of parameters that you can get off of the size distribution graph. And we'll be solving those problems dealing with borrow pits and the cubic yards of borrow required. Soil testing and earthworks, will be looking at the stresses of earthworks against partitions, and we'll be expanding that to the calculation of piles and footings. Now in Section 3, Hydraulics and Hydrology, we'll be talking about the flow of fluids in pressurized pipes and the flow of fluids in open pipes. And here we see that we'll be dealing with graphs that are in the NCEES Handbook concerned with hydraulic radius, which is important for the flow of pipes according to Hagen-Williams, and also Manning's equation. We'll also be looking at flow over weirs and the formulas involved. And we'll be dealing with hydrology, the science of the runoff of fluid, of water, from a landscape. Now, in Section 4 on environmental engineering, Yes, we'll be doing some chemistry, but I'll show you how to easily solve some of the chemistry problems that could be on the exam. We'll be looking at the wastewater treatment plant itself and getting the terms down and getting the mathematics down, talking about biological oxygen demand and how to calculate it and how to process it. Now in section 5 on beams and trusses, we do talk about trusses and the methods of solving for trusses, and we're dealing with forces in general. And when we get to beams, we're going to be looking at all the forces on beams, the reaction forces and the shear force diagram and the moment diagram, all because in section 6 we're going to want to use this for the design of beam structures. Here we're going to take the graphs and the tables that are given to us in the NCEES handbook, and we're going to learn how to use them for the solution of beam structure problems, the design of beam structures. Here we're going to take the graphs and the tables that are given to us in the NCEES handbook, and we're going to learn how to use them for the solution of beam structure problems. We'll be doing this according to the equations that are supplied in the NCEES handbook. And then we'll be going on to section 7. Reinforced concrete is maybe not a course that you took, but it is a course that is tested on in the FE exam. And here our basic idea is to try to determine how much steel we need in order to protect these concrete beams from bending. And in order to do that, the charts that are provided in the NCEES handbook, the interaction diagrams, are ones that are quite complex in order to use, but not after we view the lectures and see how to go about using interaction diagrams. So come along with us and take the FE Civil Engineering Review course. Our course is designed not to teach you civil engineering, but instead to have you pass the test. We'll start with very simple concepts on the lectures, and we'll work to the complicated nature of the formulas in the NCEES handbook. So I hope I see you in class.